There you go. Now it's recording. Okay, calculator. Let me try calculator. Oh, this is the calculator, but you don't see. I need to share the screen of the calculator. Okay, calculator screen. Share is a simulator, no? Of the calculator. No? Do you see or no? Do you see? Let me know. Do you see?
Yes.
Okay.
Yes.
Okay, super. Pay attention. I put in a calculator 15,000. Multiplication. The function exponential is located exactly in the same key of the natural logarithm. Okay. Que es el key que contiene x, pero en blue es el natural logarithm, pero en yellow, and this calculator, no, the calculator maybe is different, but it's similar. So you press yellow E, because I need the function E. And you see something like that, E power, open parenthesis. Inside the parenthesis, you copy the number, guess 0.095. Multiplication, important, the arithmetic sign, time. Thank you, the time in here. And close the parenthesis to indicate that everything is considered inside the exponential. And you press enter or equal, either way, and you get this answer. Let me copy. It's $38,785.60. Remember, it's a currency, it's a money, and you round or truncate your answer to the nearest cent, to decimal place. So 2 decimal place after the point. Okay, everyone follow me? Good or not good? Try to do in your own calculator, please. This is important, no? Because in the test, you need to do by yourself. Okay, now I clear the taskbar, and you put a second calculation that's similar, 15,000. And you put multiplication, why not? Highlight, open the parentheses, 1 plus 0.092, get the interest rate, divided by 2, get the compounding. Everything is raised power, this here part. Power, 20 power, 20 power, 20 power. Press enter, and so you get 36,874.40. I suppose that this calculator have the setup in 1 decimal place. I don't know, you can fix it in your own calculator. Let me see. You will go to the mode, maybe. Go down, float down 6. Let me increase it a little bit, 1 more, 7. And let me repeat the operation again. Let's see what happens. Exactly the same, doesn't change. Any question, guy? Entonces, okay, entonces el super fantástico conclusion is, the super fantastic conclusion is we have two quantity. The first one is future value is equal $38,785.60, and the second is 36,874.40. Okay, it's obvious. Okay, the best option is the first one. Completely opposite idea happened. See, it's a present value. Remember another problem we are doing. You need to find the price of the bond. So in this case, it's obvious. Okay, when you compute the present value, say you have the future. When you compute the present value, you get the cheaper, so the smaller price. But in this case, no. In this case, it's better for us, the greater return. Any question? No problema. Everyone follow me? Good or no? Opinion. This is a review. I need opinion. This is a review. Come on. Mason, Kennedy, opinion, Kenya, Roy, opinion. Answer me. It's okay. I understand. Hard. Okay. Too much.
Clear.
Hard. Follow me. Okay. Good. Good. All right. Let me see another opinion here. Over there. She say follow. Okay. Okay. Good. Now let's move on to the next question. Next question is pretty easy. It's about the graphic of the logarithm. So in the last class, I remember we are doing the graph, but the graph of the exponential, no? And now I am doing the graph of the logarithm. Okay, let's do it. Doing the question number 5. So we are doing the graph of the function that is f of x equal L of g base 2. I don't know, in the test, the base is 2, is 3, is 5, is 1/2, is 1/3. Okay, I try to make 2 examples, and see it's another number, you let me know. So you don't understand, I can help. Okay, okay, look, everyone know. The logarithm base 2 of 1 is 0. It's a property number 1 can be studied. Therefore, the point is 1, 0. And this is like a universal point for the logarithm function. I plot that. Boom, 1, 0. 1, 0 is this point. Okay, now I also know the logarithm base 2 of 2, so they are perfect coincidence, and the base and the number inside the argument is 1. You know that, right? So the point is the point 2, 1. I plot that 2, 1, 2, 1. Entonces 2, 1 over there, here. You want another? Yeah, well, the fundamental, the typical, we're using always is 1 in the positive part, another in the negative part. But no, logarithm negative is impossible. However, logarithm base 2 of 1/2, que es the reciprocal of the base, is -1. And the point is 1/2, -1. I plot that point. How? I plot that point. Well, half is the middle and the midpoint here, and the same between 0 1 and -1 here. Boom. I get. It's possible doing another point? Of course, it's possible. For example, logarithm base 2, because we continue doing the graphic of the logarithm base 2. The base doesn't change. That the only variable is the argument. Of 4, esto. Entonces, the point is the point 4, 2. Let me try. 4, 2. Here, over there. Okay, ready. We connected this point by the curve that represent logarithm base 2 of x. Important. So you continue and the approach to 0. The value is negative and increasing. Increasing the actual value. It's negative, but actual value is greater. And important, is similar to the idea for the exponential. In the exponential mandatory, you need to draw the horizontal asymptote, and the logarithm no. The logarithm you have como ese opposite, ese inverse function, you have vertical asymptote. Add. So this dotted line represent vertical asymptote at x equals 0. End the story. The mandatory. So you forgot the vertical asymptote, no full credit. No, you get something, no, but no full credit. Okay. And likewise happens with the base 3 or base 5 or base whatever. The same procedure. Any question, guys? Do you understand this or no? Yes or no? Okay. So you understand this. So you are ready to see the question number 6. And the question number 6 It's exactly the same. It's the graph of the logarithm, but the problem is that the base now is less than 1. Let's see, the base is less than 1. You know, it's similar, very, very similar, except that the graph is not increasing, it's decreasing. But okay, we're using exactly the same strategy. And also, why not? Look at that. And also, let me erase that one. Let's erase everything. Now our problem is do the graph of the f of x equal logarithm base half of x. Well, the same idea. Suppose x equal 1. I know very well the professor explained me that logarithm of 1 is 0. Now the point is 1,6, is the universal point. Boom. Any graph of the logarithm passing through that point. Okay, now logarithm base half of half. I know very, very well that when there are perfect coincidences between the base and the is, the answer is 1. But the point is half common. Half is here, 1 is here. I plot this point, it look like that. Logarithm base half. I cannot change the base because we're drawing the graph of the logarithm of half of the reciprocal of the base get to -1. And the point is the point 2, -1. So when you plot es 2, -1, 2, -1, I suppose que here. Entonces es similar, pero es decreasing, o sea, es en opposite direction. I suppose que likewise, logarithm of 4 is -2, right? The same idea. And so, this is the graph of the logarithm base 1/2 of x. And likewise, we have the vertical asymptote always at x equals 0. Vertical asymptote at x equals 0. You have a question? Come on. What is the question? Remember, when you type in the chat, I don't see because I see only the whiteboard. But if you activate the microphone, you can ask me directly, no? What's the problem? Question. Do you follow me? Clear? Super? No problema? We are the best? No problema? Okay. It's clear, I know. There's nothing for us. Okay. Let's continue. Now, I can.
And all you need is 3 points, correct?
Yeah. It's enough. It's enough. Good question, Holmes. Okay, 3 points is enough. And don't forget the vertical. Okay, convert the exponential. So what's the question now? The question now is question 9, no 7, sorry. Okay, we have 3 questions, no? Sub-questions. A, conversion logarithm base 2 of 1/32 equal -5. Actually, we have 3 logarithm statement, no? I need to convert to exponential. It's super easy. Okay, the format is U identification number 1, what is the base? Okay, let me try here. You identify very well the base. Okay, it's logarithm of base 2 again. 1/1024 is equal to -10. Now this statement is true. You don't try to compute that because you lost time. No. This is not the problem. The problem is change or convert to exponential. U identification. Wow, the base is 2. So this is small 2, you put big 2. The exponent is always the answer of the logarithm. Is equal to the number inside the argument. That's it. This is the conversion from logarithm statement to exponential statement. Here is 3 raised to the -5. And make it sense because when you have negative exponent, it's reciprocal. Actually, 243 is 3 to the 5th power positive. in the bottom, okay, actually it's negative in the top. Likewise, this is 2 again, big 2, raised to the negative 10 is equal 1 over 1024. Boom, final answer. Any question? No problema. No problema number 7. Let's do a number 8 now, it's completely backward. In opposite direction. So I give you exponential and you have to convert to logarithmic state. So says ABC 3 to the negative 4 is equal 1 over 81 BS 2 to the negative 5th power is equal 1 over 32 and C is 4 to the minus 3 is equal 1 over 64. Entonces, when you convert to logarithm, of course, you put the magic word log, log something. That the conversion this is logarithm of something. I asked by myself, what is the base? Base is 3, it's over, right? I put the small 3 here. I convert this base, big 3, and one small 3. And so inside the argument, I have no idea exactly what is going on. Now, however, I know that the answer can offer the logarithm is always the exponent. So for sure, negative 4 is the exponent, and this is 1 over 81. If you want, you can verify this statement in your calculator. But no, it's not a problem. It's only conversion from exponential to logarithmic. Likewise, logarithm base 2 of the 1 over 32 is equal to negative 5. And the last conversion is logarithm base 4 is the base of 1 over 64 is equal to minus 3. Boom. Done. Any question? Super clear or super confusing? I suppose it's clear. Okay, let's move on to the second page. Second page of review. Please putting off the microphone because I saw noise. Kadir. No, Kadir no. Kadir is in mute. Okay, let's move on to the another page. Let me erase the board. Okay, now I go to download this document. Oh, it's the second page. It's this. Boom, 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 boom. There you go. Let me make it zoom. It's easy. Look, the question 9 is right as a single. Single means only one. Logarithm with coefficient 1. So basically, the thing we are doing is apply the property number 5, number 6, and number 7, using together to condensing several logarithms in only one. Okay? So I want to recall property number 5 is about multiplication. So it's when you have logarithm of the any base of the multiplication to thing, to expression, to number, whatever, is equal the sum plus. It's easy to remember because it's the same operation that we are using when you multiply. Suppose that you multiply to exponential. A to the m times a to the m is a to the m plus m. So it's easy. Multiplication is addition. A division or a subtraction. Okay? The property number 6 is division. So you have two expressions, m times divided by m is logarithm a of m minus logarithm a of a. Notice que the negative guy is the guy que es located in the denominator, no? Denominator negative, numerator positive. And property 7 is easier. Is when you have power. And you have, for example, m raised to the r power, the r fly inside of the factor. Basically, in this problem, number 9, we're doing the application, these 3 fantastic properties. In order to condensing, example 8, here is 7, logarithm base 8 of z minus 5, logarithm base a of w plus 4, logarithm base 8, 8, not 8, 8. Okay, the base should be the same. There's different base. We cannot apply these properties 5, 6, and 7. It's important to understand this. Okay, so you condense in only one. So you put only one log word. Of course, the same base. Yeah, open a fraction. Entonces, any guy que es positive is this and this. It's in the top. Like a C, but the exponent is 7. Because in this case, we are using the property 5, multiplication, adding, time, and the property 7 together, B4. And this guy gets negative W to the 5th power exponent. And everything includes the parentheses, because remember, this parenthesis indicate of the argument of the logarithm function que stay at the condensing, no? Everything. Everyone follow me? Everyone understand the basic idea? Okay, let's do B. Well, B is similar, except that we have fraction, but don't be scared with the fraction. Go ahead. You have somebody ask me a question? The top is negative. The top, hold on, what's your question? Activate the microphone, please.
So the top would be positive and the bottom would be the negative.
Absolutely perfect. It's a fantastic conclusion. It's a fantastic conclusion. Okay, entonces now B is logarithm base 2 of A minus 1/3 logarithm base 2 of B plus 1/5 logarithm base 2 of C. Okay, no problem. I understand. You put only one log base 2. It's important that you understand the idea que say the problem. Coefficient 1. Coefficient 1 means that in the final answer, the coefficient in the front here is invisible 1. Okay? 7, 5, 4 go to your corresponding place in the point. So we have fraction because I can see this guy is positive. This guy is positive, okay, in the top. But okay, it's A to the 1/2 power times C to the 1/5 power. And the negative guy is B to the 1/3 power. This is one possibility to express the final answer, que es correct. 100 point for you. So you are doing that way. However, another student don't like the fraction exponent, and you can express it using radical. It's the same. This is a square root A times 5th root of C and cubic root of B. It is equivalent 100%. Either way, the way you prefer. Okay, let's do it the last one. The last one is long. Because we have how many? How many logarithms we have? We have 1, 2, 3, 4, 5, 6. Wow. Is logarithm base 5. Logarithm base 5 of x. Let me copy. Plus logarithm base 5 of y minus logarithm base 5 of z plus logarithm base 5 of capital A plus logarithm base 5 of capital B minus logarithm base 5 of capital C. Okay, don't worry. What's my job? My job is condensing everything in only one. Like that. Logarithm of base 5 and something. The positive guy es this, es this, es this y es this. Entonces, x times y times a times b in the top. And the bottom, the negative guy, z times c. Final answer. Any question? Super clear or super confusing? Let's do it now. Question number 10, que es completely backward. So in this question, we apply the property, but we have to, or we are doing condensing. However, in the number 10, no. In the number 10, we are going to do the expand. Okay, it's exactly the same application of this property, 5, 6, and 7 we studied before, but in opposite direction. And be careful. And be careful, be careful, be careful. Write the logarithm as a sum of different of logarithm, okay? And in this case, no coefficients 1. So I eliminated the exponent, put that like a front, like a factor in the front. And important, the numerical, when you expand in several logarithms, the numerical value you have to compute. Okay, basically I can see, this is easy, you expand using 3 logarithms. The first one is logarithm of base 2 of 1/16. Plus, because it's multiplication, 6 times logarithm of base 2 of w, plus 3 times logarithm of base 2 of p. And leave like that? No. Why not? Because this is variable p, this is variable w, but this is numerical. And you compute this number. And you have no excuse to don't know this. Because we have two possibilities. Do it by hand or by calculator. And we practice both now. By hand is you have no idea. You put X because there's the thing that we don't know. You convert this statement to exponential to see more clear. And when you convert to exponential, the base is 2. This small 2 now is big 2 and exponential 4. The exponent is exactly the thing I don't know. And the result is 1/16, but I know that 16 expressed like a power of 2 is 2 to the 4 power, and this is the reciprocal, is 2 to the negative 4. Therefore, in this moment, you have 2 exponential. The base is the same. The conclusion is x equal negative. And this is by hand. And my final answer, well, okay, my final answer, then I, for example, erase this part. No good, no good, no good. I put the result of this case negative 4. This is my beautiful final answer. Okay? Not only expand, the numerical part you have to compute. Okay, and the calculator, well, let's do it. And the calculator, remember, in our calculator, we have no base 2. We have a standard base. But don't worry, you put LOG or LN, because my calculator I want to show you now have no LOG. I don't know why. It's LN. It's okay, doesn't matter. You have two standard, natural or common, of the 1/16 divided by LN2. And we get the same result. I suppose that. Let's do it in the calculator. Let me share the calculator screen. I appreciate that. Do you see or no? You see the calculator? Answer me, guys. Yes, no.
Yes.
Yes.
Let me clear. New calculator. Okay, entonces es natural logarithm because this calculator have no log. Well, have, but it's hiding. I don't know exactly what you can find. It's 1/16. Close the parentheses, extremely important. Divided by another logarithm of 2, no? Present -4. Super. No problema. Do you understand the exercise?
Yes.
Okay. Let's move on to next. Okay, it's in the same question 8, no? But I want to do it now fast, not slow, like the first. Now is expand this logarithm we contain inside several expressions. And don't forget that the numerical expression you need to compute. The variable expression, no. It's indicate like that. Suppose logarithm base 3. Okay, logarithm base 3 of 81 a square b6 divided by c4 d5. Expand. 1, 2, 3, 4, 5 logarithm is supposed to be. Logarithm base 3 of 81 plus, because it's time in the top, 2 times logarithm base 3 of a plus 6 times logarithm base 3 of b minus 4 logarithm base 3 of c minus again, everything in the bottom is minus 5 logarithm base 3 of d. But leave it like that. No, you need to compute logarithm base 3 of 81. Come on, guys, try to do and let me know what the answer is. Using your own calculator or by hand, either way. Somebody waiting for you 30 seconds. Activate the microphone, no chat. Come on, we are doing logarithm base 3 of 81. No idea? No result? You are in big trouble. Big trouble on this test. Okay? No idea? You never, some people say, no, I never understand this. Okay? You want to become professional? Come on. Logarithm base 3 of 81. What is that? Eh? What is the exponent? When you raise 3, give me 81. Wow.
4.
4. So big as 4. So big as 4. Everyone understand it's 4. Somebody don't understand it's 4. Okay, you need to do by yourself. I don't know what number you can see in the test. By the way, I sent a text today. That's 4. I sent in the morning today. I sent with this email. I sent to you the link of the sky. Okay, do you receive? No? Are you aware? Okay, this will be due this Thursday is 7, 8, 9, December 9. December 9. In Friday in the morning, I need to bring that. Okay, this is a 4. You are right. This is my final answer is you replace 4 here. Boom. Final answer. Any question? What part you don't understand? Clear? Okay, one more. One more case, C. Es logaritmo base 5 of 625 x to the 5th power, y to the 6th power, z to the 6th power again, w squared. And you expand. Okay, it's easy. Remember, the guy in the top is positive. But I have to compute this because it's numerical. Plus 5, logarithm base 5 of x. Don't forget the base. It's important information. Plus 6, logarithm base 5 of y. Minus 6, logarithm base 5 of z. Minus 2, get the exponent, logarithm base 5w. And likewise, separately here, we compute logarithm base 5 of 625. Using calculator or by hand. Okay, again, nobody help me? Or again, Holmes, help me to compute that. Nobody know? For example, 4 again. Wow, it's a coincidence. It's 4, yeah, you're right. 4. It's 4, then my final answer needs to express it like that. Any question? No. Oh, yes. Okay. Oh, it's easy. Number 11 is super easy. Super easy question. Look. Is now we are using, okay, we need to compute. This is just calculator. It's impossible to do it without calculator. Is compute, evaluate, compute. And indicate all 4 decimal places. Round. So logarithm base 12. So non-standard base of the 23.5. So we're using the famous change of base formula. I want to copy here. You have logarithm of the one base that you don't know, non-standard, of the one number that I call x is equal. Logarithm, for example, you suppose another base, que maybe is standard or non-standard. Well, I suppose that when you put in the calculator as a standard of the same number divided by logarithm of the same base, db, look, it's a new one, of a. In our specific example, I have no idea what is base 12. However, I have idea about base LOG or LM because my calculator I bring today have no LOG. I have only LM. This is LM of 23.5 divided by ln of 12. So I need help, and you let me know. Okay, yes, ln 23.5 or LOG in your calculator, guys. ln 12. I don't want to switch it again to the calculator. No. I use the calculator I have in my hand here. I use LOG in my calculator. 23.5 divided by, close the parentheses, important, divided by LOG 12. Close the parentheses and press enter. Boom, I have the answer. Help me, what is the answer, guys? And you trunk it or round off to the near 4 decimal place. Okay, help me. What's the answer? Really, are you there or you are sleeping? Yeah? All right, come on, Mason, are you there? Mason. Camille.
Yes, sir, I'm here.
Go ahead, help me, put in the calculator. You have calculator or no?
Yes, sir, I do.
Go ahead.
I got I got 1.2704 or round 1.2705.
Entonces, what is the what is your in your opinion? What is the final answer?
1.2705.
Excellent. Very well.
Thank you, sir.
1.2705. because actually it's 1.270470431. For you to round off to the near 4 decimal place, I can see that the digit after the 4 decimal place is, let me see this, 1, 2, 3, 4, is 7. And 7 is greater than or equal to 5, so you adding 1. This is the answer. Everyone is agree or disagree? Do you follow me or you are totally lost? Huh?
I'm following you, sir.
I know you get. Your problem is that you are shy, no? And you don't want to participate. But okay, I understand. Okay, now the number B is logarithm 5 of 528. Okay, I put in my calculator also. Should be LOG or LN, whatever. 528 divided by LOG of 5. Okay. Put in the calculator, please. And come on, I need another participation. Always the same holes, always participate. Now Mason participate. For example, Camille, Alfonso, Keonia, Roy, etc. Okay. Yes, I focus in my whiteboard. In my whiteboard LOG 528, close the parentheses, divided by LOG 05. Come on, help me. Activate the microphone and you give me the answer. Who are you? Introduce by yourself. Who are you? Come on.
If we round it up, it will be like 3.90.
It's 3 point. Sorry, 3 point. My answer I saw on the display is 3.89.
Yeah, 520852.
Exactly. However, I need only 4 decimal place. 1, 2, 3, and 4. Oh, but this is 0. It's nothing. It's 3.8952. No, super good. Any question, guy? Who are you? What is the lady that answered the question?
Camille.
Camille. Nice for Camille. Now let's do in the last one. Yes, logarithm base half of 44. What the hell? Well, it's similar, no? It's in the calculator using logarithm 44, standard base, divided by logarithm 1/2. Be careful, in this case, in the previous example, the answer is positive always. Positive and positive. The reason is clear because the number involved in the problem, both 23.5, 12, 528, 5, are number greater than 1. However, we have 44 get greater than 1, but we have 1/2 is less than. And you need to remember that the logarithm standard of the number less than 1 is negative. Positive divided by negative, the answer that we expect is negative. This is important. You need to be aware for that situation. However, bueno, suppose que you don't know, no problem. Because you put in the calculator, but okay, surprise is negative, so I make a mistake. No, you don't make a mistake. You're doing well. 44. Divided by logarithm of 1/2, 0.5, either way. Logarithm 0.5, I put in the calculator, press enter, boom, I get the answer. What's the answer? Who help me? Come on, another participation, guy.
Negative 5.4594.
Negative, repeat again, negative
5.45.
943 1619. It's okay.
That's it.
Okay. So we need 4 decimal place. 1, 2, 3, 4. But the next digit is less than 5. So leave it there. The answer is -5.4594, right?
Yes.
Beautiful. What's your name, Mister?
Junior.
Junior. Okay. Does everyone follow me or no? I'm totally lost in the logarithm. You never understand logarithm. Some people say, no, I never understand this. It's too hard for me. I don't need that. And you want to become professional engineer, chemistry, Oh, Nercy dice we don't need logarithmic. And in chemistry, we computed something that's called a pH, and the pH, the formula involves logarithmic. Okay. So let's move on. Wow, to the complicated part. Now let's start complicated part. Okay, the exponential equation. Remember, we have two kinds of the exponential equation. One kind of the exponential equation that we can solve it without logarithmic, not necessarily apply. No. Another case, yes, it's mandatory. These two examples, 12 and 13, is a typical example in which you don't need to use a logarithm. But if you use a logarithm, it's okay. Some people say, no, I can use a logarithm always. Yes, but not necessary because we can express it, both bases, using the common base. The number involved in the base, look, you have base and exponent, no? A base and exponent. Another base, A1, A2, exponent 1, exponent 2. But we need to express both base. In this case, the base 1 is 1/3 and the base 2 is 9. And you need to discover one number that we can express the common base. I suppose que es obvio, no? What is the common base, your opinion? You have opinion or no? No idea. Huh? How you express a 9 and 1/3 using common base? No? Well, 9 is 3 to the second power, yes or no?
3 is the common base.
3 is a common base. So he said that the common base is 3. Because 9 is 3 to the second power and 1/3 is 3 to the -1. Remember, raised to the -1 is reciprocal. That's the same. Then you replace, no 1/3 anymore. It's 3 to the -1 raised to the 2x plus 5 is equal 3 to the second power, get 9 equivalent x plus 3. Okay, I like that. Now you apply the property rule of the property of the exponent when you have different level of the exponent. Suppose you have x to the second to the third. This is equal to x to the 6. Where come from this 6? That's multiplication, 2 and 3. No addition. Addition is when you multiply. Oh, it's x to the 5th. Where come from 5? 2 plus 3. But in this case, different level. So you multiply. This is 3 to the minus everything. To indicate it's minus this expression, you enclose on the parentheses because this minus affects everything. Not only the first one. No, everything. And likewise, here is 2 times everything. Okay. Now, ready if you have two exponential functions and the base is the same because the exponent would be the same. And you copy the exponent, use everything negative. The common factor gets 2, x plus 3, and the rest is algebra. Because actually, from this step to this step, magically, you convert exponential equation to linear equation. Exactly the linear equation we will solve in intermediate algebra. And the rest is distributive property. Okay, and we solve for x. For example, these 2x stay here. Why not? I move from -2 to the other side. And this -5, why not stay in the left? Yeah, I move 6 to the left. Okay, -6. It's -11 equal 4x. 2x plus 2xy. Finally, divided by 4. X alone is -11 over. Boom. Finals. And don't be scared. The answer is negative, positive, because the exponential function is nice. The domain of the exponential function is all real number. Therefore, we can accept all real number in the solution of the exponential equation. The logarithm, no. Logarithm is picky, sophisticated, but the exponential is easy. accept any value for the solution. You need to check it. Yes, if you want, you check it, but it's too long and complicated. No. So you are doing well, you answer perfect. You don't need to check it. No. And the logarithm, yes, mandatory check. And the exponential, never check. Any question? Okay, one more.
Clear, clear.
Clear. Yeah, I know. Thank you. Okay, I appreciate so much that you help me to follow, no? Because, you know, this is online hard because I don't see your face, no? When I have in the classroom, and you see your face look like back, it's because you don't understand. No? My experience like a teacher is clear for me when the student don't understand. But only look in the eyes. But in this case, I don't see your eyes. Okay, 125, right to the next. Well, in this case, it's very, very similar. I suppose that you guessing perfectly the common base is 5, right? Because 1/5 is equivalent to 5 to the negative 1 exponent. And 125 is equivalent to 5 to the cubic power because 5 times 5 is 25, and 25 times 5 again is 125. Okay, so you replace. This is 5 to the negative 1 raised to the x plus 2 equal 5 to the cubic power raised to the x. Now again, one more time, you apply the property of the multiplication different level of the exponent, and 5 minus x plus 2. Don't forget this parenthesis, it's important because if you write without parentheses like that, look, it's completely wrong because you write like that. I suppose that this negative affect only x. No, that's true. It's completely negative times this expression equal 5, 3x. Okay, in this moment you have two exponential function and the base. I create artificially, but I create the same. Therefore, the exponent is the same. Okay, and the 5 gets the base, it's gone, disappears. Now distribute it, minus x minus 2 equal 3x. Solve for x. Easy. You, for example, move this x to the right hand side, minus 2 is equal 3x plus x, minus 2 is equal 4x, or divided by 4 both sides. And reducing lowest term, this is negative 1/2, x equals x. Boom. Negative exponent again. Don't be scared. The exponential function accept any exponent, positive or negative, and even 0. Because I know that any base to 0 power is equal 1. Super clear? Wow. So I suppose that almost today we finished the review. Okay, I move for the last page. So my plan is 30 for sure. In the few first minutes, we finish the review for the test 4. And well, the rest of the time, I try to solve something about the final. One typical example of the final, not exactly the final I want to send. So I have different collection for the final, but I send one of this. Okay, look, 14. This is different. This is different because in this case mandatory, in this kind of equation, we need to use logarithm. Why? Because it's impossible. Try to find the common base between 5 and 4. No, impossible. Okay, no problem. I understand that. So you apply logarithm. What kind? Standard. Logarithm of this expression and logarithm of this expression. Okay, this logarithm working like an operator. And you have something with something, when you apply the logarithmic, it's the same because, you know, it's a one-to-one function, so no problem. Entonces, no, you apply now the property number 7. Property number 7 que allow us this exponent, que es x plus 4, you put in the front as a fact. Important parenthesis. Be sure. LOG of 5. And this is just a number that we can compute in the calculator. Equal. Likewise, 4x LOG of 4. And now, magically, from this to this, you have logarithmic, exponential equation, logarithmic equation, and this is linear equation. Because actually, this is a number, this is a number. And you are doing exactly the same procedure that we are doing in intermediate algebra. You distribute the property, then you multiply logarithm of 5 times x, and logarithm of 5 times 4. This is x times logarithm of 5, it's just a number. I understand, but it's a number. 4 logarithm of 5 is equal 4x. Well, in this case, not necessary to do anything because we have only one logarithm, no parentheses to distribute it. And solve for x. So for x. You solve for x, I try to move everything that contains x to the one side. For example, one idea is this stay here, and I bring down, I put 4x logarithm of 4 minus x logarithm of 5 and bring to the right hand side. And how do you factor out? You factor out x, que is the thing I try to solve it, and you have 4 logarithm of 4 minus logarithm of 5. Okay, you want to isolate the x. Well, it's easy. You divide both sides. You divide both sides by this number, que es weird, but it's a number, logarithm of 5, 4 minus logarithm of 5, que es, wait, this is logarithm estándar. This is 4 logarithm of 4. It's a mistake, you know. It's a LOG, it's a G, not 5. LOG of 4. Both sides. Minus LOG of 5. Both sides. This is cancel. No, this is my goal. X alone is 4 logarithm of 5 divided by 4 logarithm of 4 minus logarithm of 5. You can put it like that in the calculator, but no. This is stupid. Okay, no. So maybe you apply the property que help me to condense it. Entonces you put in a calculator, for example, in the top, logarithm of 5 to the 4th power, because this 4 I put using the property number 7 again, pero power in the exponent. And 5 to the 4th power is 625. You verify in the calculator. Look. Let me show you step by step. This is logarithm of 624. Where I come from 624? I put in my calculator 5 power 4. Boom, I got it. Likewise, in the denominator is more complicated because we have power and subtraction and division. So when you're condensing, you have logarithm, only one, not two, hello. So you put in the top, 4 to the 4th power divided by 5. And 4 to the 4th power is 4 power 4 is 625 LOG 200, sorry, 255 divided by 5. Because it's minus 5. Okay, and in my opinion, now it's easier put in the calculator in that way. I put in the calculator, yeah, I truncate the answer or round off the answer in the 4 decimal place. It's doing. We have LOG 625, close the parentheses, divided by LOG again one more time, one time, two times, one at the top, one at the bottom, because I condensed it that. 256 divided by 5. Press, close the parentheses, don't forget, press Enter. I get the answer. I need help. What answer you get in your own calculator? Help me. Who help me? Come on. I prefer female. Come on. Coenia. Carolina.
1.6357.
Carolina say 1.6357. And that's it, right?
Yeah.
The rest one. Okay, super. This is it. Guys, do you understand very well this too long procedure? Yes or no? Do you understand or no?
It's long, but it's understandable.
Exactly. Thank you for help that. You say it's long, but if you follow it step by step, you have no. Okay, guys, I recommend you stop here. Why not? Because you have time. So basically, next time we're doing question 15, 16, 17, 18, and 19. Done. That's number 4. And thus I present the one version of the final for the student they need to take. Remember, this is not mandatory. Some people say, no, my overall grade, professor, it's easy to compute the overall grade. Remember, we have 8 tests. 4 chapters online and on paper. You have the score and Blackboard. And you adding everything and divided by 8. So for example, you get 85. 85 is so because B, and B is good for you, you don't need to take the final. I said, no, professor, I want to improve. Okay, take the final. Suppose that you failed the final, let's stay the same. Because the arithmetic of the final is just addition something. See, your grade is 0. Entonces, you stay in the same grade. You have worried to complete what? Say again, Clifford, you worried to complete what?
The pi, like the little lessons that you have to do. Do we have to complete those?
No. Remember, okay, in the Alex, you need to do only homework, que es extra credit, and test. No pi. No pi, no. Another teacher complete the pi. No. The only assignment I posted for you, test 4. And the homework, I don't remember if it's 7, 8, or 9. The last homework associated with the chapter 4 and the test number 4. I suppose you don't have no time to take the homework. Okay, no problem. You take the final, you put the grade of the final. The homework is the 3 homework you get grade score greater than 80, you increase in 10 points extra. This is extra. No time, no problem. Got it? Clear?
For test 4, there's 2 tests to do. One that you sent an email and one to do.
This
Okay.
Thursday, do both.
All right.
Friday in the morning. Friday in the morning, I open my computer, I check in Alex, I grade 1 by 1 paper. And that's it.
And if I understand, there's another test that you'll be willing to give us to make up marks?
No. The idea at the beginning was clear. You have 4 tests, online and on paper. Right. I introduced the idea for the final. The final is one help I try to give the student can need. Suppose you fail 1 test.
Right.
Okay, take the final. You say, pero the mathematics I explained last time, you average the 8 tests and plus the point of the final. Okay, it's no average, not divided by 9. It's plus something. Plus something. Always help. Suppose you are doing nothing is 0. So say, okay, no problem, I stay the same. I have B. Okay?
Okay, I understand. Thank you.
Another question about the test? I want to stop recording, but I cannot. Okay, don't worry. Well, bye-bye. Good night for everyone.
Good night, Professor.
Bye, Professor. Thank you.